Over 2,000 years ago, a mysterious disease was recorded in the ancient Chinese medical book, the Neijing. The key symptoms described were deadly periodic fevers associated with enlarged spleens. Over the next hundreds and thousands of years, the same symptoms were being documented in ancient Egypt, Greece, India, and Rome. This disease had a significant impact across civilizations, and even today it remains one of the most widely spread infectious diseases. This disease is malaria, which translates from Italian to bad air, and it was historically believed to be caught from inhaling deadly supernatural mist. We now know that malaria is caused by the single-celled parasite, Plasmodium falciparum, which is transmitted to humans through the bite of an infected mosquito. The parasite will then eventually make its way to a red blood cell and invade it. When inside its red blood cell host, it develops into many more parasites, which burst out of the host cell and go on to invade others. The aim of my PhD research is to understand how this invasion process occurs through investigating the molecular interactions between the parasite and the host. In the world today, approximately 250 million cases of malaria are reported each year, resulting in over 500,000 deaths. This burden is greatest on the African continent, where 95% of cases and 96% of deaths are recorded. To put this into perspective, it is estimated that a child dies from malaria every single minute. In at least 3,000 years, we have been unsuccessful in eradicating malaria, and we are further challenged by increasing rates of drug-resistant strains. The urgency for new antimalarial therapeutics requires a greater understanding of this ancient and complex relationship between Plasmodium falciparum and the human red blood cell. So far, the parasite has been the focus of invasion research, whilst by comparison, its host cell has received little attention. In fact, the red blood cell is widely viewed as passive during invasion, despite it being a highly dynamic cell and one that is extensively coated in various molecular structures. And more recently, we have also seen that when particular red cell structures are missing, Plasmodium falciparum struggles to invade. The goal of my research is to bring attention to the host cell. During my PhD, I aim to identify the role that these red blood cell structures play during invasion and understand why they are used by the parasite. By the time I conclude my talk, 3 children will have died from malaria. It is my aspiration that my research will offer new insight into tackling this disease and put an end to our long struggle with Plasmodium falciparum. Thank you.